You just wrote a function. You run it, expecting one clean answer, and the console shows your answer. But right below, it sits a stray word, none. Where did that come from? This video clears up three things. The difference between returning a value and printing it, where a function actually lives in memory, and how to drop a function into a real program full of loops and conditionals. Let's practice by writing a new function. Here's the specification, the contract. Write a function called diff_by. It takes two inputs, n and d, both integers greater than 0. It returns true if d divides n evenly, and false if it does not. To check our work, we test two cases. Diff_by of 80 and 3 should give false because 3 does not divide 80 evenly. Diff_by of 80 and 4 should give true because 4 does divide 80 evenly. Two tests, one expecting false, one expecting true. A natural first attempt looks like this. Inside the function, if d mod n is equal to 0, print true, otherwise print false. Now we test it. We write print and inside it, diff_by of 80 and 3. We expect false and we do get false. But look closely because right underneath, Python also prints the word none. That stray none is a clue that something is off. We printed the answer from inside the function, but the function itself handed nothing back to the outer print. So the outer print had nothing to show but none. Why did that none appear? Here is the rule. If a function runs all the way to its end without ever hitting a return statement, Python quietly hands back a special value, none. Our first attempt only printed. It never returned anything. So the function's own answer was none. Printing shows a value on the screen. Returning hands a value back to whoever called the function. Those are completely different actions, and mixing them up is exactly what produced that stray none. The fix is to return the value instead of printing it. So we swap print true for return true and print false for return false. No parentheses needed after return. Run the first test again and the stray none is gone. We simply see false. We can go one step further. The condition d mod n is equal to 0 is already either true or false on its own. So instead of an if and an else, we return that comparison directly. Return d mod n is equal to 0. Shorter, and it behaves the same on our first test. Now we run the second test. Print diff_by of 80 and 4. We expect true because 4 divides 80 evenly, but Python prints false. Something is wrong. Look at the remainder. We wrote d mod n, the remainder of d divided by n, but the specification asked whether d divides n. We want the remainder of n divided by d. The two were flipped. We corrected to return n mod d is equal to 0, run both tests once more. 80 and 3 gives false. 80 and 4 gives true. Both correct. This is exactly why we kept two test cases. So what actually happens in memory when we define a function? First, recall plain variables. When we write a equals 3, the name a is bound to the value 3 in memory. B is bound to 4 and C is bound to 7. Names pointing at values. Now, a function. The instant Python sees the def keyword, it does not read or run the indented body. It does not care what that code does yet. All it records is that a new object exists, a function object, bound to the name is even, a name pointing at some code. Think of that stored function as a black box. Once it is written and it works, we stop caring how it does its job. We only care that we hand it a number and it hands back true or false. The code inside does not run until we make a call. And when we do call it, the returned value can be bound to a variable, just like any other value. We set a to is even of 3, and a is bound to false. We set b to is even of 4, and b is bound to true. We set c to is even of 10, and c is bound to true. The definition sits still. The calls are where the work happens. Now let's use is even inside a larger program. Here is a loop over the numbers 1 up to, but not including 10. For each number I, we ask if is even of I. If that call returns true, the number is even. So we print I followed by the word even. Otherwise, we print I followed by the word odd. Reading the output, 1 is odd, 2 is even, 3 is odd, 4 is even, and so on, all the way to 9. Notice this code is not wrapped in a def. It is not a function. It is just a loop that calls the function we already wrote. Why can't we drop a function call right into the middle of an if statement like that? Because a function call is just an expression. Python runs it, it evaluates to a single value, and that value takes the call's place, exactly like 3 plus 2 becoming 5. So it's even if I becomes true or false, and the if simply reads that result. A call returns one value, and that value can go anywhere a value is allowed. Inside a conditional, inside a loop, anywhere. And because our program leans on a function, it is remarkably easy to change. Want to label the numbers 1 through 100 instead? Change the 10 to 100. That is the only edit. Run it again, and every number from 1 up to but not including 100 is labeled odd or even. Now imagine if even were far more complicated. It would not matter. You would still call it in a single line and trust its answer without stopping to reread how it works. That is the power of a function. Let's gather the ideas. First, a function with no return statement automatically hands back none, so return a value. Do not just print it inside the function. Second, a function is an object bound to a name in memory. Python does not examine its body until you actually call it, and that call's return value can bind to a variable. Third, because a call is an expression, you can drop it straight into loops and conditionals to build larger programs. Write the function once and use it everywhere. To practice what you just learned, this course has free exercises and AI graded feedback on ludium.ai. The link is in the description.